Hello everyone, you are welcome to another session of Python for All. In this first lecture, we will talk about basics of Python. We will look at definition of Python, syntax, data types, and operators. Let's dive straight in and begin with the definition. What is Python? Python is an interpreted, general-purpose, high-level programming language. It was created by Guido van Rossum in 1991 and further developed by the Python Foundation Software Foundation. It is easy to write and also easy to debug. It is dynamically typed, which makes it flexible, but also it could be prone to errors. Python supports object-oriented programming, making codes more modular and reusable. Python comes with a large standard library, which runs on a variety of platforms. Let's dive straight into the syntax of Python. The syntax of Python is a set of rules that defines how a Python program will be written. Python is very readable. In other words, Python is a very readable language, and its syntax is designed to be as simple and as intuitive as possible. We'll look at the following syntax in Python. The first of them is the white space. Python uses white space to delimit blocks of code. Indentation is used to indicate the start and the end of a block of code. The next is the keywords. These are reserved words that have special meaning in Python. Keywords cannot be used as variable names or function names or class names. We will see examples of these keywords in Python. The next is the identifiers. These are names that are used to identify variables, functions, classes, and other objects. Identifiers must start with a letter or an underscore, and they can contain letters, numbers, and underscores. You should note that identifiers cannot start with a number. Having said that, we will move straight to the next syntax, and they are referred to as operators. These are symbols that are used to perform operations on variables and expressions. The last but not the least are comments. Comments are used by developers, Python programmers, to provide documentation for Python program. Comments are not executed by the Python interpreter. The next, we'll look at examples of keywords in Python. To get examples of keywords in Python, you simply open your Spider console or go to your terminal, open the Python interpreter, enter the text, import keyword, and then move to the next line and pass the instruction print keyword.kwlist, which means print keyword list. What pops up on your screen are all the reserved keywords in Python. You can see them: false, none, true, and, assert, async, await, break, class, continue, def, del, elif, s, except, finally, for, from, global, if, import, in, is, lambda, non-local, not, pass, or, raise, return, try, while, with, and yield. These are all reserved keywords in Python. They cannot be used as variable names. They cannot be used as class names. They cannot be used as function names. Having said this, we'll move straight forward to examine a typical Python syntax. Same as we have done earlier, you open your Spider IDE, go to the console, and you begin first on the first line. You can see by passing a comment. A comment is always preceded by a pound symbol or an hash symbol, then followed by a function definition beginning with def, the function name, and right inside the function block we can see first a comment saying that this is a function. So like I mentioned earlier, what we do with comment is to enable proper documentation of our code so that users or other developers can easily follow the codes we have written. It makes it much more easier even when the same Python developer or programmer comes back to his code. He or she can easily, follow the code he or she has written. It makes it much more easy to edit the code, to further, develop the code, debug, and do all sort of activity that you need to carry on with your code. And then right inside, after the statement, you have the if statement followed by a return statement, an else block, and outside the function block you have the print instruction, passing instruction to print factorial of 5. If you write exactly this, and you should also take note of the indentation right inside the function block. The indentation is very, very important. The indentation oftentimes you have in Python is 4 white spaces, but if you use Spider IDE, your PyCharm IDE, your indentation is automatically, your code is automatically indented. But if you use some other IDEs that don't have this automatic Python indentation, then you have to ensure that you put in the right indentation of 4 white spaces. Now let's take a look at a breakdown of the above program syntax. First, the hash symbol is used to start a comment. Here I would lay emphasis that these comments are often single line comments. As we go downstream, when we discuss functions in our subsequent lectures, you will see how we can write multi-line comments using triple quotation marks. Next is def, def keyword. It is used to define a function. In Python, every function begins with a def, just like a short form of definition. It begins with a def space and then followed by the name of the function. Okay, after that you have your parentheses, and right inside the parentheses you have the parameter of that function. And that leads us to the next, which we talk about, factorial, which comes immediately after the def. Factorial here in this case is the name of the function. Okay, and thereafter we have the parameter of the function, which is denoted by n. Here we have just a single parameter of this function. Mind you, you can have multiple parameters. We will also see how these are represented in our subsequent lectures with examples. We'll see positional arguments, we'll see keyword arguments, and you would get to understand how these arguments can easily be parsed in Python functions and also in when you're writing your classes. Okay, the next is the if statement. The if statement is used to check if the value of n is equal to 0. Here I've introduced a comparison operator which we are yet to discuss in this lecture, but just know that that double equal sign simply denotes equal to. Then after that follows the return statement. If you look vividly at that function, you will see that we have two return statements, because we have passed in a conditional to say if n is equal to 0, simply return 1, or else, if not or, please, else if n is not equal to 0, what should the function return? Okay, that's what the return statement stands for. The return statement simply stands for, a statement to return a value from a function. Okay, next after that is the print statement. The print statement can either be inside the function block, but you cannot, it depends on what the programmer wants to do. It depends on what you want to do. You may want to print while returning a value, but oftentimes when you have to deal with large code development, printing right inside the function block, the classes block, becomes a little bit clumsy and irrelevant. So, but just know that what the print function does is to return a value to the console. In other words, it prints a value to the console. Having said this, we'll go straight away to look at the major features of Python. You probably might be asking yourself, why Python? What is the so-called noise about Python? The so-called hype about Python programming. You want to know, what is the main reason, or why should I learn Python? I will proceed forward to enumerate a few of the reasons why you should be interested in learning Python. First of them is that Python has a large standard library. These libraries can be used for a variety of tasks, such as file input output operation, networking, data manipulation, data analysis, data visualization, image manipulation, and there are a lot of operations you can or activities, so to say, you can do with this standard library base of Python. The next that is most catchy is that Python is open source and free. Unlike most programming languages, you have to have a copyright to use and or distribute applications developed with those languages. But in case of Python, it is open source, it is free to use, it is free to distribute. Applications developed to Python are free and can easily be commercialized without any copyright infringement. The next is that Python has a large active community. Here we have a community of active users and developers who contribute to the language and its ecosystem daily. What it means is that if, as a developer, you run into problem, you can easily find help from this active Python community. The last but not the least that I will mention is the platform independence of Python. This makes Python code to be easily run on a variety of platforms, including Windows, Mac OS, and Linux, just to mention a few. Python is a very powerful and versatile language that is used for a variety of applications, such as web development, data science, artificial intelligence, software development, scientific computing, automation, education, just to name a few of these applications. It means that application of Python is vast across all human endeavors. Here I would quickly mention some specific examples of Python application. Web framework. We know of the popular web framework Django and Flask. It is built on Python. We have the deep learning framework, examples of PyTorch, TensorFlow, Keras, Tilo, etc. We have it being used for scientific computing, and we find NumPy and SciPy library as examples of this scientific computing library or application of Python. The next is that Python is used for data analysis and data visualization, and pandas and matplotlib library of Python is used in this regard. Having said this, we will proceed to look at the next subject matter, which are data types in Python. What are the various data types in Python? We will look at all the various data types in Python in trying to establish a foundation of knowledge for what we will subsequently use in our programming exercise, program development, application development, or software development. The first of such data type is the numeric data type. These data type represent numbers such as integers, floats, and complex numbers. Example can be seen on the table with the description on the left hand side of the table denoting the data type and example. You can see that the integer simply represents whole numbers, either positive or negative, while the float, which in the mathematics paradigm we refer to them as decimals or fractionals, are called float in Python. They are noted with numbers either positive or negative containing decimal points. The last, which is the complex data type. Of course, we have the complex data type from our knowledge of mathematics. Here we have a numeric data type having two components, the real part and the imaginary part, with the imaginary part being denoted with the j vector or the I vector. The next of the data types in Python is the Boolean data type. This data type represents a true or a false. In binary form, it could either be a 1 or a 0. We will see all of these as we begin to take programming exercise and when we go far more into this lecture of this lecture series, I mean to say. The next is the sequence. The sequence represents ordered collection of items such as lists, tuples, and strings. Examples are shown on this table. The list is designated with square brackets, while elements of the list could either be a string, a float, an integer, or a mixture of both or all of them. The next is the tuple. The tuple is denoted by the parentheses. Okay. When we move to the next lecture, which we'll have and we'll talk about Python data structure, we'll see the distinction or the difference between a list and a tuple, and then we'll begin to see how we can use the list and the tuple. Then I would give more detailed examples with practical implementation of this data type. The last on that table is the string. The string is represented with an expression or object or item being encapsulated with either a single apostrophe or double apostrophe. We will see the use of either single or double apostrophe. Actually, in Python, when you write your Python code, you are supposed to be consistent. If you want to use single apostrophe, you have to use single apostrophe all through. If you want to use double, you use double all through. So consistency also plays a role in this case, or while you're writing your code or trying to make the choice of which of the apostrophes you intend to make use of. The next is the set. The set represents an unordered collection of unique items. The set is designated as seen highlighted in red with a coil brackets or brace brackets. The last but not the least that we will talk about today is the dictionary. The dictionary represents a mapping between keys and values. For example, you see every element of a dictionary has a mapping between a key to a corresponding value. Also, you can see here that the dictionary is also designated with the coil or the brace bracket. But the difference between the dictionary and the set is that the dictionary here contains a mapping of keys to values. In other words, every item of a dictionary is a key value pair, while in the set it is simply an unordered collection of items. Having said this, we will move straight to the last topic to be considered in this lecture, and they are simply operators. We have seen operators when we highlighted examples of Python programming syntax, but here we will dwell more on the various type of operators with their respective symbols, so that it becomes easy for beginners to know these corresponding symbols and then be able to know when to use them while writing their codes. The first of such operators is the arithmetic operators. Of course, from the name, arithmetic simply denotes these operators are used for performing arithmetic operations. Of course, the first of them is the plus, followed by the minus, then the asterisk, which denotes multiplication, the forward slash, which denotes division, the double forward slash, which denotes floor division. As we proceed in this lecture series, I will also illustrate, show you examples what we mean by floor division, how we use the floor division, how also we do some you will see examples of this, and then you begin to appreciate and then see how all of these operators are being used. The next is the double asterisk, which denotes exponentiation. Okay, for example, in a mathematics paradigm, we refer to that as power. For example, if you have x raised to power 2 in Python, it is written as x double asterisk 2. The last of them, which is the percentage symbol, simply denotes modulo division. Also, I would explain what this means, and you will see how we will use this effectively in virtually all of our codes when we want to try to do some comparison, try to see. But you will see actually how each of these are being used as we proceed in this lecture series. Okay, the next is the assignment operators. The first of them is the equal sign. The equal sign here does not mean equal to, as in the case in mathematics or in our general mathematics paradigm, but here it simply represents an assignment. What it means is that symbol is used to assign a value to either a variable, an expression, or a constant. Okay, the subsequent assignment operators here, you can see them as a combination of the single arithmetic operators and the equal sign. They simply represent a decrement by whichever arithmetic operators that come before it, or an increment in it. You will also see how we use all of this. In fact, this set of assignment operators are effectively being used as a shorthand form of making Python code so readable and a bit compressed. Just like I said earlier, one of the advantages of Python is that Python can be written in plain language, as if you're writing English language. So whatsoever you can express, or whatsoever way you can express yourself, as in just to write in English, you can also write Python code like that. So that's also one of the reason why Python has so much gained this popularity, that he is almost becoming the number one programming language. Of course, there are still other programming language competing with Python, but it's gained so much popularity because of the ease of learning Python. And that's actually one of the goal of this lecture series, to ensure that even a novice or a beginner with no prior knowledge of programming can easily become an intermediate programmer within a space of 0 to 3 months, if you follow this lecture series and do all your practices, personal development, and within, even before the 3 months, you're already an intermediate developer. So having said that, we will proceed to the next operator, which is the identity operators. Here, as the name denotes, we have the is and the is not. We are simply trying to use these operators to kind of allocate a memory space for a variable or an expression in Python. The next is the membership operators. Here we have the in and not in. We will see how these membership operators are used subsequently when we begin to write our codes and show examples of different code syntax. The next is the logical operators. Here we have it as the and, the or, and the no. Not, sorry to say, please, the not. The last but not the least of them is the comparison operators, and we have them listed on the table with the symbols and their corresponding meaning. You can see here, equal to in Python is denoted by double equal sign, and not equal to in Python is denoted by an exclamatory mark followed by an equal sign, and also your less than or equal to, greater than or equal to. Having said this, we'll proceed finally to talk about what is popularly known as the Zen of Python, written by Tim Peters. If you open your IPython console in Spider and simply type import this, what you will get is this: the Zen of Python. The Zen of Python is like an amorphism in Python that guides every Python developer. And I will proceed to recite what you will see printed on your screen. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules, although practicality beats purity. Errors should never pass silently unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it. Although that way may not be obvious at first unless you are Dutch. Now is better than never, although never is often better than right now. If implementation is hard to explain, it's a bad idea. If implementation is easy to explain, it may be a good idea. Namespaces are one honky great idea. Let's do more of those. With this, we have come to the end of this lecture. If you have any comments, do not fail to put it in the comment section. Also, if you find any ambiguity in this lecture, please put your question also in the comment section. Till then, sit back and watch out for the next lecture.